Alright, this is the second video for section 2.6. And topic number 3, we're solving a rational inequality. And in this video, I'm going over example number 2, the second example. So very similar to the first one, what we need to do is we need to move everything to the left side so that we have 0 on the right side. So right now, we have x on the right side. So let's go ahead and subtract x from both sides. I will have 8 over 6 minus x is now greater than or equal to 0. Step number 1 was to move this x to the left side. Okay? Now, in order to simplify or subtract these two fractions, or one of them is a fraction, I will now write common denominators. So x will get multiplied by 6 minus x over 6 minus x. And if you're wondering, where did you get 6 minus x from? Well, that is the denominator for the first fraction, so that now they have a matching denominator. Let me go ahead and write down a single fraction, writing the numerator as what I'm circling in gray. That is going to be my numerator. I'll write 8 minus x times 6 minus x. That is my numerator, all over the denominator of 6 minus x, and that is greater than or equal to 0. We need to simplify the numerator now, so that we can find the zeros of the numerator and the 0 of the denominator. So if I distribute the negative x, not a positive x, you guys, it's a negative x, I will get 8 minus 6x minus times, well, negative times negative is positive x squared, all over 6 minus x is greater than or equal to 0. Now, if you look at the numerator, can I put this in standard form? X squared minus 6x plus 8. So the numerator was just all out of order, but if I write this in standard form, can you see how the numerator now can be factored? I can factor this numerator as x, and is it negative 4 times negative 2 positive 8, and they add up to negative 6. So that's perfect. And I'm going to copy down the original denominator. So this is great. We got it simplified all the way. I was trying to see if anything on the numerator and the denominator cancels out, but they don't. So this is done. Now we're going to find the zeros of the numerator and the denominator, okay? So I'll move the work over here. Hold on a second. I'll draw a line. And I'll go ahead and write down that function one more time. I have x minus 4 times x minus 2. Whoopsies. X minus 2. And the bottom of the fraction is 6 minus x. And we're trying to solve this inequality. All right, look. Now we're ready to find the zeros of the numerator. Zeros of the numerator are x equals, look, if factor is x minus 4, 0 must be positive 4. And what's the other one? If the factor is x minus 2, the 0 must be positive 2. So these are the zeros of the numerator. Let's find the 0 of the denominator. The bottom of the fraction is 6 minus x. And when is that equal to 0? Well, that's equal to 0 when x is equal to positive 6. Because 6 minus 6 is 0, isn't it? So we found all the zeros. Let me circle these for you so that we can go ahead and plot these on a number line. So let me go ahead and do the number line down here. So on the number line, I will have the smallest number of 2 on the left, 4 right here, and 6. Remember, 0 of the denominator always gets an open circle because the bottom of the fraction can never be 0. So go ahead and plot an open circle at 6. Open circle at 6. But at 2 and 4, it follows the sign or the inequality symbol. And you look at the symbol is greater than or equal to 0. So these two will actually get closed circle because it can be equal to 0. Okay? And when the denominator, when the numerator is 0, that is when the whole fraction will turn into 0. So this one is a tricky case because, well, denominator, we don't really have to think about it. It's always an open circle. But numerator can be a closed circle, and that depends on the symbol, the inequality symbol. Now, after that, guys, it's the same. It's the same. I'm going to go ahead and start plugging in some numbers to the left and right and all these intervals. So let me go ahead and start with the one on the left. I will plug in a test point. X equals 1 because 1 is smaller than 2. And I see the function is written right here. So let me plug it into that factored form. 1 minus 4, 1 minus 2. We're going to try to divide that by 6 minus 1. And we want to see if that is greater than or equal to 0. So let's see. The numerator is -3 times -1. The bottom of the fraction is 5. I got some check to do. I have 3 over 5, right? Positive is greater than or equal to 0. And look, this is a true statement. Because this is a true statement, I'll go ahead and highlight this region as my answer. Okay, and I go about my way. Let me go into the next interval. So next, I need to pick a number that is in between 2 and 4. What number is in between 2 and 4? I can think of 3. I'm going to go ahead and plug in 3 into the second one. Plug in x equals 3. Okay, let me zoom out, or yes, zoom out so that I can see the function. So if I plug in 3, 3, and 3 in there, I will get 3 minus 4 times 3 minus 2 over 6 minus 3 is greater than or equal to 0. This is what we are trying to test. So let me see if this is true, you guys. It is -1 times +1 divided by 3 is greater than or equal to 0. But if I simplify the left side, that is -1/3 is greater than or equal to 0. Negative number is not greater than 0. This is a false statement. So that interval where 3 came from is not the answer interval. So we skip that one. Let's go to the next one. How about we check the one in between 4 and 6. So as you guessed it right, I will now plug in x equals 5 because 5 is in between those two. So if I plug in 5 into this function, this is what I'm going to write down, okay? 5 minus 4 times 5 minus 2 over 6 minus 5. And what we want to see is that greater than or equal to 0? Let us see. Look at the green part. The numerator is 1 times 3. The denominator is 1. And we want to see if that is greater than 0 or equal to 0. Greater than or equal to, so both are fine. The numerator is 3. It's just 3 is greater than or equal to 0. Isn't that absolutely true? Because this is a true statement where we got that 5 from. That must be an answer interval. So I'm going to go ahead and come over here and I will go ahead and highlight that interval. This is the answer region too. Alright, the very last interval that I must check now is to the right side of 6. Okay? Right side of 6. So how about I plug in a number that is bigger than 6? I will plug in x equals 7. Okay, let me plug in x equals 7. I apologize, my little daughter is singing. 7 minus 4 times 7 minus 2. Let's divide that by 6 minus 7. And we want to see if that is greater than or equal to 0. Numerator is 3 times 5. The denominator is -1. Shh. I don't think infants understand shh. All right, the left side of the inequality isn't that negative 15? Negative 15 is greater than or equal to 0. What? That is not true. Negative number is not bigger than 0. So the last interval failed on us. So we have answers. The answer is graphed here, okay? Everything to the left of positive 2, but 2 will get a bracket because it has a closed circle. Everything in between, including 4 all the way to not including 6. So what I just have graphed, I'm going to go ahead and write that as a solution here, okay? I wrote so big. What can I do? I may be able to just I just need a little bit of room to write my answer. All right, give me 1 second. Noah, not Noah. Well, Luna, stop it. Mommy, almost done. Everybody's excited for this moment because we are about to write the solution. Here is the solution. Okay, the one that is going to the negative infinity, but we'll end at 2. But we need a bracket for that, don't we? We need a bracket because 2 is a closed circle. Draw the union symbol. And the 1 looks like a dumbbell, right? That starts from 4 with the square bracket because it's a closed circle. That one will only go to positive 6. But since it has an open circle, let me just close a parenthesis. So this one was a little more difficult because we have 3 boundary points to test. And, well, if we have 3 boundary points, it cuts the number line into 4 intervals. So I had to check 4 different intervals. But, you know, you take your time. It's a great practice. I will come back to go over the third example in just a minute.